Welcome to another deep dive. Today we'll be tackling the biggest secrets the universe has to offer.
Definitely some big questions.
Yeah, definitely. So dark matter and dark energy.
Hmm.
We're going to try to unpack the top 10 unsolved questions about these cosmic enigmas
Hey,
based on the research that, you've pulled together. And um, what's so intriguing about this is that, these invisible entities make up the vast majority of the universe,
yeah,
but they're still shrouded in mystery.
pretty much.
And so get ready for some mind-blowing concepts
Sure.
that really challenge the foundations of physics as we know it.
Absolutely.
It's
So it's fascinating how these invisible forces govern, the universe's structure and evolution.
Yeah, so let's start with the most fundamental questions here.
Okay.
What are dark matter and dark energy,
Right.
and why are they such profound mysteries?
Yeah.
We know they exist because we can observe their gravitational effects,
Right.
but they don't interact with light like normal matter does.
Exactly. It's like trying to study a shadow without knowing the object that casts it.
Oh, that's a good analogy.
Yeah. So we can see the effects of these entities on galaxies and the universe's expansion, but their true nature remains elusive.
Okay, so we observe the effects but have no clue about their composition.
Pretty much.
But if we can only observe these gravitational effects, how can we even be sure that dark matter and dark energy aren't just gaps in our current understanding of gravity?
Yeah, that's a great question, and it's something that physicists grapple with constantly. While modified theories of gravity have been proposed, they haven't been able to fully explain all the observed phenomena that we see.
Yeah.
And the evidence for dark matter and dark energy comes from multiple sources. Things like the cosmic microwave background radiation and the distribution of galaxies. It's not just about missing gravity, but rather about a missing source of gravity that behaves in ways our current theories can't account for.
Okay, so there's definitely something there.
Right.
It's just we don't know what it is.
Exactly.
So let's try to delve a little deeper into dark matter.
Sure.
So your research mentioned several candidates for dark matter particles.
Right.
What's the latest on these elusive particles?
Well, one of the leading contenders is WIMPs, which stands for Weakly Interacting Massive Particles.
Okay.
And these hypothetical particles would be heavy and interact very weakly with regular matter, which is, what makes them so hard to detect.
Yeah, makes sense.
But interestingly, the concept of WIMPs arises from supersymmetry theories,
Okay.
which predict partner particles for all known particles in the standard model of particle physics.
So it's linked to broader theoretical frameworks, not just kind of random guesses.
Exactly. The search for WIMPs isn't just about finding dark matter. It's also about testing these fundamental theories of particle physics.
Right.
And then we also have things like axions, which are super light particles that could have been produced in the early universe. And there are sterile neutrinos, which are like heavier cousins of regular neutrinos that interact even more weakly. So each candidate has unique properties and potential detection methods.
So it's like a whole lineup of potential suspects.
Yeah, pretty much.
But this 5.1 ratio of dark matter to regular matter is particularly intriguing.
Yeah.
This isn't just some random number, is it?
No, it's definitely a crucial clue. It suggests that whatever process created the imbalance between matter and antimatter in the early universe
Right.
might also be responsible for the abundance of dark matter.
Interesting.
So understanding this ratio is key to unlocking the mysteries of both cosmology and particle physics.
So really fundamental to everything.
Absolutely.
We've been exploring some really fascinating concepts about dark matter.
Yeah.
Now let's shift our attention to dark energy.
Okay.
It's like the universe just decided to hit the gas pedal
Yeah.
and accelerate its expansion.
And the fuel for that acceleration is what we call dark energy.
Okay, so it's pushing everything apart.
Pretty much.
Our research mentioned the idea of a dark sector,
Right.
a hidden world of dark matter interactions.
Yeah.
So what if instead of two separate entities, dark matter and dark energy are just like different expressions of the same underlying phenomenon?
Yeah, that's a possibility that physicists are actively exploring. It's called the unified dark sector hypothesis. And it proposes that dark matter and dark energy aren't completely separate, but arise from a single, more fundamental concept.
Okay, so instead of two separate mysteries, we might be looking at two sides of the same coin.
Precisely. Imagine discovering that electricity and magnetism are different aspects of the same force. That's the kind of paradigm shift a unified dark sector would represent.
Wow.
It would completely revolutionize our understanding of the cosmos.
The research also touched upon the density of dark energy.
Right.
and how it doesn't actually match up with what quantum mechanics predicts.
Yeah.
What are the implications of this discrepancy?
Well, this is what's often called the cosmological constant problem. It's a major headache for physicists.
It sounds like.
It suggests that our current understanding of either gravity or quantum mechanics might be incomplete. Quantum mechanics predicts a much higher density of vacuum energy, which is related to dark energy, than what we observe.
Okay.
So this mismatch could point to some new physics we haven't even considered yet.
So our current models are kind of missing a crucial piece of the puzzle.
Exactly. Like trying to solve a complex equation with only half the variables known.
Yeah.
This discrepancy highlights the limitations of our current understanding and motivates the search for new theories that can reconcile gravity and quantum mechanics.
So fascinating. And what about the possibility that dark energy's density changes over time? The research suggested this could dramatically impact the universe's ultimate fate.
Right. If the density stays constant, we're likely headed towards what's often called the big freeze,
Okay.
where the universe expands indefinitely, becoming colder and more desolate.
The big freeze.
Hmm.
A rather bleak ending.
Yeah, kind of depressing. But if dark energy increases, we might face what's called the Big Rip, a runaway expansion that tears apart galaxies, stars, even atoms.
Oh, wow.
On the other hand, if dark energy weakens or reverses, the universe could collapse in on itself. The Big Crunch.
Okay, so a lot of different options.
Yeah, the ultimate fate of the universe really hangs in the balance.
It's unsettling yet amazing to realize how the universe's fate hinges on this mysterious dark energy.
And that's precisely what makes studying dark energy so compelling. It's not just about understanding the universe's past, but also peering into all of its possible futures.
So the research also mentioned efforts to directly detect both dark matter and dark energy.
Yeah.
What do these experiments actually involve?
Well, for dark matter, experiments are searching for those elusive particles like WIMPs and axions. Some are buried deep underground, shielded from cosmic rays,
Okay.
using extremely sensitive detectors to catch even the faintest interactions. Others use strong magnetic fields, hoping to detect axions as they convert into photons.
So it's a combination of shielding from interference and maximizing sensitivity.
Exactly, trying to catch these fleeting interactions. On the dark energy front, we can't really catch it directly,
Oh, yeah.
but we can observe its effects on the universe's expansion. Astronomers are creating these incredibly precise maps of galaxies to measure their distances and movements over time.
Okay.
And this data helps us constrain the properties of dark energy and test different models.
So we're trying to understand the invisible by carefully observing what we can see.
Precisely. Like trying to study the wind by observing how it moves leaves and branches. By carefully analyzing the expansion of the universe, we can gain insights into dark energy.
I'm really struck by how these mysteries are driving so much innovation and pushing the boundaries of scientific exploration.
Absolutely. It's inspiring to see how the pursuit of these cosmic enigmas is leading to breakthroughs in technology and theoretical understanding. The quest to understand dark matter and dark energy isn't just about these entities themselves. It's about pushing the limits of human knowledge and exploring the fundamental nature of our universe.
It really makes you wonder what other secrets the universe holds and what future discoveries await us. What are some of the most promising directions for future research in this area?
Well, there are so many exciting avenues to explore.
Yeah.
One is building even more sensitive detectors for dark matter,
Okay.
perhaps leveraging quantum technologies to increase our chances of observing these really elusive particles.
Okay.
Another is improving the precision of cosmological surveys
Okay.
to better understand the evolution of dark energy over cosmic time.
So refining our tools and expanding our observations.
Exactly. And we also need to keep pushing the boundaries of theoretical physics, developing new models and frameworks that can better explain the observations
Yeah.
and address the mysteries that continue to baffle us.
This has been an incredibly insightful journey into the heart of the universe's biggest secrets. I feel like we've only just begun to scratch the surface of this vast and fascinating realm.
And that's the beauty of it. The more we learn, the more we realize how much more there is to discover. Each new insight opens up new questions, new avenues of exploration, new possibilities for understanding our place in the cosmos.
Welcome back to the final part of our deep dive into dark matter and dark energy. We've journeyed through a cosmic landscape of some pretty mind-boggling concepts,
We have.
from the potential for a unified dark sector to the universe's possible fates. It's been an incredible journey.
It has.
And I have to say, it's both exhilarating and humbling.
Yeah.
to realize just how much we still don't know about the universe.
It really does highlight how much more there is out there to discover.
So as we wrap up our deep dive into these cosmic mysteries,
Okay.
what are some key takeaways that you hope our listener will walk away with?
I think first and foremost, it's important to remember that dark matter and dark energy aren't just these theoretical concepts that physicists came up with. They're
Yeah.
like fundamental components of the universe.
Yeah.
They're shaping its structure, its evolution, and its ultimate destiny.
They're really the invisible architects of the cosmos.
Precisely. And while we haven't directly detected them yet,
Right.
the evidence for their existence is overwhelming, based on their gravitational effects on visible matter.
So they're leaving their cosmic signatures all over the place.
Exactly. And deciphering those signatures is what's driving so much of the innovation in physics and astronomy. We're building these incredible experiments, pushing the limits of technology, developing new theoretical frameworks,
Yeah.
all in pursuit of understanding these enigmatic entities.
It's a testament to the power of human curiosity
It is.
and our determination to unravel the mysteries of the cosmos.
Absolutely. And while we may not have all the answers yet, every new discovery brings us one step closer to comprehending the true nature of reality.
Well, this deep dive has been a fantastic exploration of the universe's biggest secrets.
It has.
We've talked about the potential candidates for dark matter, the mind-boggling properties of dark energy, the possibility of a unified dark sector.
Yeah.
From all of this, what's the one thing you want our listener to really hold on to?
I think the most important takeaway is this. The quest to understand dark matter and dark energy isn't just about physics.
Okay.
It's about understanding the fundamental nature of reality. It's about our place in this grand scheme of the universe and the endless possibilities that lie ahead as we continue to explore. So keep looking up at the stars, keep asking questions, and never stop wondering about these invisible forces that shape our universe.
It's been a real pleasure exploring these cosmic mysteries with you.
Likewise.
Who knows what incredible discoveries await us in the years to come?
I can't wait to find out.